Stay safe and happy learning to all of you. Station heat rate of a thermal power plant is the index of efficiency of that plant. It is expressed in kilocalorie per kilowatt hour and defined as amount of heat in kilocalorie required to generate 1 kilowatt hour or 1 kWh of energy, or that is electrical energy. Mathematically, it is equal to heat input in kilocalorie, that means total heat input by any means, by coal or by oil, total heat input in kilocalorie divided by units of electricity generated in kWh. Now, lower the station heat rate, more efficient is the plant, less is the cost of generation, and less is the tariff, and less is the burden on your pocket. Not only that, with the lower station heat rate, the greenhouse gases emissions are also less and our environment is protected. Now see here, this is a model of thermal power plant. This is boiler, this is turbine, and this is generator. Combined efficiency of thermal power plant is not more than 40% if it is not supported with cogeneration system of cogeneration. 40% efficiency. In SI unit, 1 kilowatt hour is equivalent of 860 kilocalorie. Converted to joule, this will have to be multiplied by 860 into 4.186, equal to approximately 3600 kilojoule. So 1 watt is 1 joule second. Now 860 kilocalorie is equivalent to 1 kilowatt hour. But in India, CERC, that is Central Electricity Regulatory Commission, has allowed 2375 kilocalorie for generation of 1 kilowatt hour. Earlier it was 2500 kilocalorie per kilowatt hour, but in its constant endeavor to improve the efficiency, in 2011, Central Electricity Regulatory Commission of India allowed 2375 kilocalorie for generation of each kilowatt hour. Now the combined efficiency of this boiler, turbine and generating system is not more than 40%. What is the efficiency then? 860 by 2375. This will come approximately equal to 36%. So in India, no thermal power plant are supposed to run below 36%. What will happen if they run inefficiently? The tariff policy in India is cost plus. And the thermal generators will not be compensated for their cost if they consume more than 2375 kilocalorie per generation of kWh. So it is in their own interest to be efficient and generate power as efficiently as possible. So now we are clear how station heat rate affects our pocket and affects our environment. More is the station heat rate, more coal will have to be burned, or more diesel has to be consumed. More coal has to be burned or diesel has to be consumed, more greenhouse gases to emission to the environment, and we are environmentally more unsafe. Not only that, suppose some generator generates at 2200 kilocalorie per kWh. If some generator consumes 2200 kilocalorie per kWh, there is less cost of fuel. Indian coals produce approximately 4000 on the higher side to 3500 kilocalorie per kg. So less is the amount of heat input, less will be the tonnage of coals to be transported, reducing in transportation cost. So it is the interest of mankind, interest of the society to keep station heat rate of thermal power plants as low as possible. It is already running very inefficiently at the rate of 40%. Of course, if the system is a cogeneration system, means waste heat are used somewhere else, then efficiency may go higher, but not above 50%. So for the lower station heat rate, our system is more economical and more cleaner. Hope I have been able to make you understand how station heat rate affects our pocket and affects our environment. Thank you. Stay safe and happy learning.